Hello and welcome to another walkthrough. Now this time it will be Edexcel IAL P2 May 2025, which I have never seen before. So this is going to be a blind solve for the entire paper under the real exam conditions. So along the walkthrough, I might be making mistakes, which I'll correct if I realize in the walkthrough. But if I don't, I'll annotate the video and I'll try to explain the worked solution and the thought process as simply as possible. At the end of the walkthrough, I'll mark the paper anyway. For those of you who make mistakes a lot of times, you might benefit from seeing me making a mistake and correct it later. So this walkthrough is not meant to just show you the destination of the solutions, but also show you the journey to the destination. If you feel like jumping to a particular question, you can use chapters in the description. Otherwise, stick around. You might be getting some tips along the way. If you are ready, I'll see you in there. Okay, here's the paper, P2 May 2025, and I'm going to start the timer now. Okay, let's go. Number 1. Find the first 4 terms in ascending powers of x of the binomial expansion. Right, so just the first 4 terms. You have to know that for each term, it's going to be of the form ncx, and then the first term to the power of x and the second term to the power of n minus x. Or actually, if we want to be strict about the order of the term there, so it's just the first term to the power of n minus x first, and then the second term to the power of x. I mean, you can swap that if you want to expand fully, but that's fine. And it's just the sum of, like, the whole thing will run from x equals 0 to x equals n. So the first term would be n to the power of n minus 0. That's the first term. Plus, and then n, which is 7c1, 1 to the power of 7 minus 1, and this will be the second term minus 4x to the power of 1. Okay? We want the first 4 terms, so we got to keep going. So the second one is going to be, the third one is going to be 7c2, 1 to the power of 7 minus 2, and minus 4x to the power of 2. Now, as you can see, if you have done enough questions, you will see that the power of the first term will keep decreasing by 1, and the second term will keep increasing by 1, right? So I'm just writing for the method here, and then 1, 2, 3. Now the last term is just 7c3, 1 to the 7 minus 3, minus 4x to the power of 3, okay? Just like that. So, of course, the first term is 1, Second term, well, 7c1 is just going to be 7, right? So, nc1 is going to be n, So, 7 times, well, this is what? Minus 4x to the power of 1. So, minus 4 will times 7 to be minus 28 here. So, we get minus 28x, right? The second one, 7c2, you can plug that in the calculator. So basically just 7 times 6 divided by 2. Well, I forgot to, no, I didn't forget anything. That's right. 7c2 means 7 times 6 divided by 2. So that is 21. 21 for this. And 21 multiply, well, this you will get 16. So 21 multiply 16, let's use a calculator to help me with that. 21 multiply 16. So we get 336. Is that right? 7. 21 multiply 16. 336. This is x squared. And then the last one, probably you have to use calculator there. 7c3, right? That's 35. Times 1 to the 4 doesn't count, times 4 to the power of 3, but there is a minus sign there, so this is minus 2240 x to the 3, because it's minus 1 to the 3, so you get a negative term there. Okay, that's done for part A, right? And then part B. In the series expansion of that, where k is a constant, the coefficient of the term in x squared is that, right? So we got the previous part here already, so we're just going to do 5 times kx and then times the one we got above, right? Okay, like that. Okay, you know what, I'm just going to check the first part again, because you can't be too careless about this. I'm just checking the second term, 16 times 21. We got that right? 16 times 21. Yeah. And then this is 4 to the 3 times 7, C3 times 64. Yeah, I think I'm happy with those. Okay. And this is part B. The coefficient of term x squared is 1316. So how do we get x squared from here? So you got to do 5 times the x squared term there, and kx times the x term to get the x squared term. So 5 times 336 x squared, and then the other one would be minus k, 28k x squared, right? If you multiply these two, yeah. If you multiply these two, you get this, and that is the only those are the only x squared terms, yeah. So we equate this to 1316 x squared, and then of course we cancel the x squared. So k is just 5 times 336 minus 1316 divided by 28. Just solving that equation basically. All right. Okay, let's use calculator. So fraction 5 times 336 minus 1316 divided by 28. Yeah, is it 28? Yeah. Okay, so it's 13. Okay, here we go. That's it. That's done for the first question. Number 2. The line joining points this and this is the diameter of the circle. Find the equation of C. Well, if these 2 points are on the diameter, that means the midpoint will be the center. Yeah. So center, yeah, I'm just going to write center here, would be minus 2 plus 4 divided by 2. And 5 plus 15 divided by 2. So that's how you find midpoint. You just add them up, divide by 2 for each coordinate. Yeah. So it would be, that's 2 over 2 is 1. That is 20 over 2 is 10. So 110 is the center, right? And the radius is just, you can do, Pythagoras of the points on diameter there and divide by 2 to get the radius. Yeah. So I'm just going to do, this will be the diameter. So minus 2 minus 4 squared plus 5 minus 15 squared. So radius is just diameter over 2 and that over 2 there, right? Yeah. So we get what? Square root, this is 6, so 36 there in the first bracket. And the second one is 100. It's 10 squared. So square root of 136, yeah, divide by 2. And so that's the radius. Let me just check. 36, yeah. Well, but then, yeah, okay, we can simplify this. So 2, right? Well, let's use calculator. How do we simplify that? 2 root 34. So this is just root 34, right? Yeah, it's just root 34 because we need to divide by 2. Now, the equation is then x minus h, which is 1, is just the x and the y of the center, plus y minus k, which is 10, equals 34 then, because that's r squared. Yeah, we need to put in the equation. Part B, hence find the exact coordinates of the point on C that is nearest the x-axis. All right, so nearest the x-axis, we should get an idea of this circle first. So it's 110, so this is 10, this is 1 maybe. And the radius is about 5-ish, about 6, so should look something like this, right? Not touching x, but yeah, because the radius is just about 6-ish. So the distance nearest, the exact coordinates of the point nearest the x-axis would be this point then. Make sense? This lower point. So we know that this distance is root 34, right? Because that's the radius. That means this distance, yeah, that exact coordinates of the points on C that is nearest the x-axis. So we need to find this distance from x-axis to that point. So that will be, because this is already 10 units above the x-axis, because that's the y coordinate of the center, right? So this will be 10 minus root 34. Okay, So that is basically the y coordinate of that lower point. What about the x coordinate? Well, the x coordinate will just be the same as the centers, yeah, because it's along the same, vertical there. So basically it's just the x coordinate of the center is 1, so it's 1 comma 10 minus root 34 basically. Okay, so that would just be the exact coordinates of the point on C that is nearest the x-axis. There you go, done. Okay. Okay, number 3. We get given figure 1 here, shows a sketch of the curve with equation this, where x greater than 0. The points P, 1, 11 and 4, 5 lie on C, right, as shown. The region R, shown shaded in figure 1, is bounded by C and line segment PQ. Alright, use algebraic integration to find the area R, right? Okay, we can see that the area we want is below the line and above the curve. So if we find the equation of the line first, and we do y line minus y curve and integrate that, we're going to get the area. And putting the limits of 1 to 4 in, yeah, we should be fine. So we find the equation of the line first, yeah. So we use y minus y1 equals mx minus x1. That's probably the fastest way. So we do y minus y1. I'm just going to make 1 then, yeah, using 111 point P there. Well, m is just finding the gradient, so 11 minus 5 delta y over delta x. 11 minus 5 over 1 minus 4. Gotta go the right order there, so the gradient is negative here. And this is just x minus 11, sorry. Wait, hang on, I put the wrong coordinates here. This is y minus y1, 11, and x minus x1, which is 1. Almost. So the gradient here is basically 6 on top and 3 at the bottom, minus 3 at the bottom, so that's minus 2. So this will be minus 2x and plus 2 if you expand the minus 2 into the brackets, yeah. And then this will be y, if you move minus 11 to the other side as well, you're going to get that. So it's y equals minus 2x plus 13. That's the equation of the line. So the area R here is then integral y of the line, which is this guy, minus y of the curve, which is given there, yeah, that's thing, 3x plus 16 over x squared minus 8. This is the y of the curve, right? And then we do dx, and then we put the limits of 1 to 4, because that's from P to Q, left to right, all right? And then we're going to just find this integral, and that's going to be the answer. That's the plan. Okay, so we're going to be careful here integrating this. So let me just simplify first. So minus 2x minus 3x, that's minus 5x. And then we have the rational term, which is minus 16 over x squared. I'm just going to write 16 x to the minus 2, like that, yeah. Sorry. And then we have 13 minus 8, that's plus 21, yeah. Okay, and then we're going to put into the box like that, so minus 5x, so minus 5x squared over 2, minus 16, so integrating, we would get minus 16. You add power by 1, you get minus 1, so this becomes a plus because you need to divide minus 1 as well, and this is x and minus 1, or 1 over x, so I'm just going to put that, yeah. And then this is just 21x, and that's it. Putting 1 to 4 in there, that should be the answer. Okay, we want area, but it doesn't say exact, but okay, let's make exact first. Well, I would just do it like this. So minus 5 over 2, again, 4 squared minus 1 squared. I prefer doing it like this, 16. And then you can do 1 over 4 minus 1 over 1 plus 21, 4 minus 1. So rather than putting the limit, find the upper and lower limit and subtract them, I just find each term, doing upper and lower limit on their own, and then add them up like this. Yeah, you can see the difference. But in this way, I mean, it's more efficient to me, yeah, particularly if you want to do mental math, but I guess I'm not going to do mental math here, right? So minus 5 over 2. So in the brackets, that is just 16 minus 1, so that's 15, plus 16 times 1 over 4 minus 1, yeah, plus 21 times 3. That's all it is. So 27 over 2, or 13.5. Let me just check the input of the calculator there. 16 minus 1, yeah, that's fine. Okay, everything is good, so I'm just going to go with that. That's the exact answer. Okay, number 4. The function of x is defined by that, where a, b are constants, given an x plus 3 is a factor of fx, show that blah blah blah. Okay, so x plus 3 is a factor means that if we put f minus 3, we got to find the critical value, and the critical value of x plus 3 is minus 3. Put it in the function and equate that to 0, because it's a factor means that the remainder is 0, like this. This is factor theorem or remainder theorem. So a minus 3 to the power of 3 plus b minus 3 to the power of 2 plus 5 minus 3 minus 3, like that. Yeah, I'm just double checking. All right. 0 equals minus 27a plus 9b minus 15 minus 3, right? Yeah. Okay. So we just simplify this whole equation. Well, let's see. So we should divide everything by 9, yeah? So that's minus 3a plus b. 18 minus 18 divided by 9 is minus 2. So we just rearrange, so b equals 3a plus 2 as required. Yeah? So that's good. Part B. Given further that when f x is divided by that, the remainder is that. So again, the critical value of 2x minus 1 here should then be 1 over 2, right? So it's 1 over 2, f1 over 2 instead. And we're going to equate that to 7 over 4. And then I'm just going to substitute that whole lot in. So a 1 over 2 cubed plus b 1 over 2 squared plus 5 times 1 over 2 and minus 3. So 7 over 4 equals 1 over 8a plus 1 over 4b plus 5 over 2. 5 over 2 minus 3. So that's 5 minus 6, which is minus 1 divided by 2, right? So it's minus 6 over 2, yeah, minus 1 over 2. Okay. And if we simplify, so if we add if we add 1 over 2 on both sides, 1 over 2 is basically 2 over 4. Because if we want to merge that to the other side, it's just plus 1 over 2 over 4, right? So that's just 9 over 4. Okay, on this one. Like that. So we have two equations now. And we can solve simultaneous, right? Let's see. Well, I would maybe multiply this by 4. So I get 9 equals 1 over 2a plus b. And you see that we can, like subtract these two equations. So if I move everything so that b is the subject, you can have 9 minus 1 over 2a like that, yeah? And yeah, you can equate them basically because it's b equals b. So 3a plus 2 equals 9 minus 1 over 2a like that, right? Yeah. So you just collect the term here. So it's 3.5a on the left and 7 on the right. Yeah. So a is just 2. If a is 2, that means b is 8. Just solving using this maybe. Yeah. If a is 2, that means b is 8. Yep. And that's it. That's done. Part C. Using algebra to find quotient and remainder when f(x) is divided by x minus 2. Algebra. Well, that includes long division. But it's okay. We can use the theorem here, which is also an algebraic method. So we're going to do, so now f(x) is, a is 2, so there's 2x cubed plus bx squared plus 5x minus 3. Remainder, we're just going to do f2. That's also possible because this is an algebraic method. So f2 is 2 times 2 to the 3 plus 8 times 2 to the 2 plus 5 times 2 minus 3. So that's 16 plus 32 plus 10 minus 3. So 48 plus 10 is 58, so 55, yeah? That's the remainder there, yeah? Our remainder is that. 48, 58, 55, yep. Okay. Oh, we haven't got the quotient. Oh, yeah, I think we should use long division now because they also asked for the quotient. Okay, I should have done that then. Didn't see that it wants quotient too, so we should have done this. And then x minus 2. Well, that's good because we can use remainder theorem to check if the remainder is the same as 52. Let's see. So the first dividing into the first, we get 2x squared, so that's going to be 2x cubed, and then multiply back, we get minus 4x squared. Subtracting them, we get 12x squared here. Pulling that down, we get 12x squared plus 5x. The first dividing into the first, we get plus 12x, right? And then multiplying that, 12x squared minus 24x. That's going to give me 29x if you subtract them. Pulling this down. And then first divide into the first, we get plus 29. So this is 29x minus 58. Yeah. So minus 3 minus 58 is 55. Yep. So quotient will be 2x squared plus 12x plus 29, and our remainder is 55. Okay, that's just it. Okay, 20 minutes passed. Number 5. The table here looks like trapezium method. Using the trapezium rule with all values of y in the given table, obtain the estimate for that. Okay, yeah, we're gonna go from minus 2 to 7. All right, so it's 1/2 times the strip width, which is the distance between these x values basically, which is 1.5, and times is easy. Well, you just do the first one, the first y, which is 12 here, plus the last one, which is 0.023, and then all the rest will have to be added and multiplied by 2 and added to in the brackets there. So it's like the second one, 4.243 plus 1.5. Just going to do this line here, plus 0.530 plus 0.188 plus 0.066, like that. Close brackets 2 times. Okay, equal. Well, gonna put that in a calculator probably. 0.5 times 1.5, that's the first 2 numbers. Well, I would do brackets like that first, yeah? Like bracket and then bracket, 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 like that. So the first one is 12 plus 0.023, that's the last one, yeah? Plus 2 times in the bracket, and we put in the bracket here 4.243, yeah? Plus 1.5, yeah? Plus 0.530 plus 0.188 plus 0.066. Yeah, so that's everything, I think. Let me just double check my calculator entrance here. 12 plus the last one, and then 2 times the second one, the third one, the fourth one, the fifth one, 0.066. Yeah, everything is good, so I'm just going to go with that. 18.80775. Now, if we want 3 decimal places, right, it's just going to be 18.808. Yeah, that's it. That's part A. Part B. Using the answer to part A and making your method clear, estimate that. Okay. BI, integral of that. Well, we have to find the connection between this and this. If you use a law of indices, you will see that that is basically just if you split the one. So this is an index of to the power of x plus 2. So you can split the power like this, yeah? You will get that, right? So basically this is the same as this, which is what you got earlier. Or you can take this out of the integrand. That would just be 1 over 4. So basically it's just a quarter of what you got in part A, right? That. I'm just going to use a more precise value. So I'm just going to do equal and then answer times a quarter. Yeah, that makes sense. So that's 4.7. Just going to do 3 decimal places too, like that. Yeah. Okay. Well, you know what? I'm just going to round to 2 because it's like a follow through, so it shouldn't be as precise. Maybe just going to use that 7.0 instead. Okay. And part II, right? So part II, we have 2 to the minus x and 2x. Interesting. Okay. Well, we have this, right? We can have a crack on integral, so we can find this. Yeah, this is just basically the answer to part A divide by 3. You just move 3 down, because this is 3 times the integral of 1/2 to the power of x. So if we want just one of them, not 3 of them, we divide by 3. So I'm just saying that we are okay with this. Now, because we are okay with that, and that is the same as 2 to the minus x, right? Because 1 over 2 is 2 to the minus 1, and 2 to the minus 1, and to the power of x is 2 to the minus x. The reason I'm saying this is because we have this, right? That's 2 to the minus x there. So that's just 1. Okay, we can find that. Now, what about the 2x? Well, 2x here is a little trickier. Well, no, it's not. We just integrate that manually. We just use the answer to part A just to estimate the first one. The second one, we should find the exact integral, right? So it's basically integral of that plus 2x dx. It means we're going to have the answer from part A divided by 3, yeah, plus the integral of 2x dx from minus 2 to 7, yeah, like that, okay? So that is just what? That whole thing, just going to write again, yeah, plus, so 2x, right? We integrate that, we get x squared, because it's x squared over 2 times 2, so x squared is just basically 7 squared, yeah, minus 2 squared, yeah, so that should be the answer there. So 18.808 divided by 3, and then we plus 49, and then we minus 4. Okay, so that's the answer there, 51.27. Just going to keep 2 decimal places, like that. Okay, and that's done. Number 6, part I, solve that. Okay, so solve a log equation is base 2. So if we move the log term on the left side, well, number 2 here can be put as a power of 4 minus x. So it's going to be log base 2 of 4 minus x to the power of 2. Well, minus log base 2 of that whole thing, yeah, equals 3, right? So we can merge the log term using log properties, 4 minus x squared, because you can merge them like this, yeah. Just going to write like this, yeah. That's the whole denominator is x plus 7 divided by 2. Because it's subtraction, so you divide one by another, like that, yeah. And, well, 3 is just log base 2 of 8, right? You can just work backwards there. It's just log base 2 of 2 to the 3, basically, yeah. Okay. So that means we can just take out the equation and say this. So this is basically 8, and we move x plus 11 over 2 to the other side like that, yeah. and we can cancel that. 2 and 8, we get 4 here. So it's basically, if we expand this, we get x squared minus 8x plus 16 equals 4x plus 44. Yeah. Okay, so that's x squared minus 12x. Well, 44 subtract from 16, we get minus 22. No, 32. Right? No, 28. Sorry. Is that right? Yeah. Yeah, okay. Yep, I'm just checking. So we can factorize this. I think we can do 14 and 2. Right? Yeah, 14 and 2 there. Is that right? That should be right, yeah. So it's going to be x equals 14 or minus 2. Now, don't just go with always the positive value. You should try put these two answers back to the original log equation, which is this guy right here. Put into every x, see if anything gives you an argument of minus in the log. Like, for example, if we put 14 in here, of course, you get 4 minus 14, that's minus 10 in the log, which is undefined. So we're going to reject 14, because the minus 2, you will get log 6 here instead. And minus 2 being here, no problem, right? So minus 2 works here. So that means x is minus 2 as only one answer. Okay. Next, part II. The curve C1 and C2 with equation that and that meet at point A. Find the exact coordinates of P, writing your answer in the form log A or n, comma B. Well, we just equate them, right? So 3 to the 2x plus 1 up here equals 6 times 3 to the x. Well, we can solve an exponential equation in an exponential way, which is to simplify the same power first. So I'm just going to divide this into this, yeah? So you should get 3 to the x plus 1 equals 6. Is that okay? So you just subtract the power from 2x plus 1. You get just 1x plus 1. And to solve this, you just undo the exponential, which is to do log on both sides, and that will just give you log base 3 of 6. So x is just log base 3 of 6 minus 1. Okay, but that's not it. Okay, so we have to merge them into the same log term. So we know that 1 can always be put as log base 3 of 3 like that, right? So now I have log base 3 of 6 divided by 3 instead, which is log base 3 of 2. Yeah, just use a little log property to simplify that basically. So if x is that, what is y? Well, y is going to be, I'm just going to use the second one, 6 times 3 to the log base 3 of 2. Well, we know that if we have a to the log base a of x, that's just going to give you x, right? So that means this is 6 times 2. Yeah, just pull down the 2 there, because the 3 and the log 3 will cancel, because they are inverse functions to each other. Yeah, all right, so I'm just going to keep this around here. Okay, and that means this is 12 then, right? Yeah, I'm just checking. Yeah, that should be fine. So that means the coordinates of P would be log base 3 of 2, comma 12. Yeah, they're both integers. Good. Number 7. Yep. Part I, a geometric series begins with that A find the sum to infinity of this series. Okay, so geometric series, if we are asked to find the sum to infinity, that means this must be a convergent series, i.e. r is less than 1 or greater than minus 1. So, okay, so r is basically the second term divided by the first term, or the third term divided by the second term, and they should be equal, and that is 0.8, yeah. Yeah, they are equal, yeah. And a is just the first term being 10, so that means sum to infinity is just from the formula a over 1 minus r. So a is 10 divided by 1 minus 0.8, so that's going to give me 50. Yeah, 10 divided by 0.2. 0.2 is basically 1 over 5, so if you do 10 divided by 1 over 5, it's basically 10 multiplied by 5, which is 50. Okay. Part B. Given that the kth term of the series is less than 0.0005, use algebra to find the smallest possible value of k. So the k term, so ak, yeah, equals a times r to the n to the k minus 1. That's the geometric formula, okay? So 10 times r, which is 0.8 to the power of k minus 1, and it says that less than, so less than 0.0005, like that. Yeah. Okay, so we're just going to solve this log equation, inequality maybe. So that dividing by 10, we get 0.000, like 4 zeros here, extra 0 there. And then we can take log, right? So I'm just going to do this slowly. Yeah? If we take log on both sides, it's still going to be, you know, nothing wrong with this. Still the same thing, no flip. But then if we want to make this term the subject, right, we're going to divide by log 0.8. And log 0.8, if you try that in a calculator, should be a negative number. That means when we divide the right hand side, which is this whole thing, I just don't want to say that, divided by log 0.8 here, notice that I flipped the sign already, yeah? And then k will just be that thing, add with that, right? So basically log 0.000, 4 noughts, yeah? 5 divided by log 0.8, yeah? And then you add 1 from this, because you want k, so k is greater than 45.38, yeah? That means the smallest possible value of k would be just the first integer that k can be, so k is 46, right? Just the smallest one, because it's got to be greater than 45.38, so the smallest one is 46. Part II. An arithmetic series begins with that. Given that the sum of the first n terms of the series is Sn, find the greatest possible value of Sn. Okay, so, well, okay, so A is 850. D instead, so the common difference is basically 850, well, you gotta do the second minus the first, right? So it should be this, which is minus 7 then. Okay, so A, well, Sn, right, is the first n term, so you do, what's that again? 1 over 2 times 2a, which is 2 times 850, plus n minus 1 times d, which is minus 7, right? That's the formula. 1 over 2 times, well, you have n outside as well, yeah, right? Well, let me check. 1 over 2a plus l times n. That's the formula I definitely remember. It's just the first plus the last term divided by 2 times the number of terms. So, but L is basically a plus n minus 1 times d. So that's going to be 2a. This is 2a, and then n minus 1 times d. And outside I have n over 2. Yep, that works. Okay. And if we simplify that, right? Oh, we want the greatest possible value of Sn. Greatest possible value. Well, okay, I see. So we're just gonna go until, because look, if you keep subtracting the series like this, there will be a point where you start getting negative numbers, right? Like if you keep doing minus 7. So you can't just go forever to maximize the values. If we want greatest possible, we're gonna stop somewhere when it's before getting to be a negative number, okay? So how about we just find an first, where to stop, where an is just around 0. So let's make it less than 0. What's the first term that will make an less than 0, right? So I have an being the first term, 850, plus n minus 1 times minus 7. And we're going to put this less than 0 to find what n should be before it gets to negative. So 850 minus 7n plus 7 less than 0. So n must be 7n must be greater than 857. So n is greater than 122.4 or something. Yeah, is that right? Yeah, 122. Okay, wait, no, 122.4. Yeah, that's okay. So if it's 122, it's not yet negative, but if it's 123, it's going to be negative, right? So if it's term 123, it's going to start being negative now. That means we're going to stop at 122. Make sense? Yeah, we're going to stop at 122. So n is 122. That means we're going to put here S122 is going to be the maximum, right? Yeah, because we're going to stop when it's just the last positive number, which is 122. Okay, now I'm going to plug everything in the formula there. So that's going to be 121 times minus 7, like that. Okay, everything is fine. So let's just use a calculator. So 122 divided by 2 is 61 times brackets 2 times 850 minus 121 times 7. Yeah. Okay. Let me just check the calculator entry there. Yeah, everything should be fine. So 52033 as the answer there. Okay, that's the answer. Greatest possible Sn. And number 8. Okay, part I. Solve for 0 less than x less than pi, the equation that. Okay, giving the answers in radians in the form of k pi, where k is a rational constant. Okay, we're going to use a cast diagram, and if you are not very proficient in cast diagram, I suggest you check out my video. I just made the video on the cast diagram because there have been requests on that. So there you go. Just go check the video, yeah? And let's use cast diagram here. So don't forget to check it out and come back here, yeah? So the first step is to arrive at what I call the trig angle number equation, right? So if you divide both sides by by 3, you're going to get this. Yeah? Okay. Which is basically 1 over root 3. Alright? Now, this is the step where you can use the cast diagram now, because you got a trig function, an angle expression. It can be just x or something in terms of x like this, a little more complicated, equals a number. So, cast diagram. Well, this is a tan of something giving you a positive number being root 3 over 3. So you're going to be looking at the first quadrant and the third quadrant. So it's these two guys, and they are the same straight line here. And the principal angle, yeah, will be this guy and this guy. So principal angle, I use alpha. It sounds principal, yeah, alpha. Okay. Now the principal angle, I always suggest that find, no matter whether this is positive or negative, you're going to find a positive, the modulus of that. But the sign should be kept to find the right quadrants, right? So this is separate thing. So when you find only the principal angle, make it positive. And this is arctan root 3 over 3, right? Now I happen to know, because I know arctan 1 over root 3, which is the same as this. So arctan 1 over root 3 is just pi over 6. So this is going to be pi over 6. That means that little angle here and here physically is pi over 6. Now, after you got the principal angle, you got to be careful, because sometimes the angle expression here is not quite the right, like the same thing as they give in terms of domain. So they give the domain of x, but they want to, like the angle expression here is different, it's 2x plus pi over 5. So you need to modify the domain first. So because x is less than pi but greater than equals 0, so 2 pi plus pi over 5 is going to be is just 2 pi. Yeah, you just multiply this by 2 and plus pi over 5. So that's going to be what? Hang on. 11 pi over 5, right? Just add 10 pi over 5. Yeah. 2 pi. Yeah, it's 2 pi plus pi over 5. Yeah, that's right. Okay. And this would just be 0 plus pi over 5 is pi over 5, right? Okay. Yeah, I think I'm okay with that. So this will be the domain where you can keep subtending, sweeping for the angle. You can't do negative, so there's no point going this way. So you're going to be sweeping this way. So the first one you would get. So we are finding the angle for 2x plus pi over 5 first. The whole expression of angle. Not just x, but 2x plus pi over 5. The first one that makes sense is probably that, is alpha. We don't know what alpha is yet. Oh, we do, pi over 6. Because alpha is pi over 6, right? Which is less than pi over 5. So alpha itself, which is this first angle, is not applicable. So we got to take it out. We're not taking pi over 6. Yeah, because the lower bound of this whole expression is pi over 5. All right. So we're going to go the next one, where the next one will be this one, right? This one here. So that is just 1 pi plus alpha. So I'm going to go like this. 1 pi plus alpha. Okay, because alpha is pi over 6. And let's go to the next one. So the next one, well, if you already got the first one, this is the first one, pi over 6, which we didn't take it. And the second one, this is pi plus pi over 6 is basically, if we make that, it's going to be 7 pi over 6, right? Yeah, I mean, if you want to make it easy, you can just keep adding either one of them by 2 pi. You're going to get the next ones. So for example, we can have here 2 pi plus pi over 6 for the next one. Or keep adding by pi, basically. Yeah, and this is definitely within the bounds, right? Because this is 12 over 6, so that's 13 pi over 6. Is that in the bounds? I think this one should still be, yeah, likely. Yeah, so that should be just 2 answers. So let me just check that. So 13 over 6. No. So that's 2.166, right? We're going to compare it to the bounds here, 11 over 5. Yeah, so this one works because it's still less than 11 over 5, which is the bound here. Yeah. Okay, and I think the next one will be out of the range already. So we just take these two. Now after we got these two, we're going to solve for x accordingly. So that would just be 7 pi over 6, right? The first one. And the second one is just 13 pi over 6, yeah? Yeah? So that's still 2x plus pi over 5. So that means x is just 7 pi over 6 minus pi over 5 divided by 2. Yeah, for the first one. And the second one, 13 pi over 6 minus pi over 5, also divided by 2, like that. And then we solve. We want the answer in terms of pi, so we're probably not going to put in a calculator, because that's going to give you a decimal maybe. So we're just going to do manually. So that's 35 minus 6, right? 35 minus 6 would be 29 pi divided by 6 times 5 here is 30. 30 times 2 is 60. Yeah, let me check. 35 minus 6, yeah, 29. 29 over 30, yeah, okay. First one is fine. The second one, 13 times 5 is 65. 65 minus 6 is 59. So similarly, this is 59 pi divided by 60. All right, 65. Yep, I'm okay with those. So I'm going to go ahead and answer those, yeah. So that's it, yeah, cast diagram method. Go check the video. Yeah, there's practice in there as well. Second part, so for that, again, the equation this. Okay, another cast diagram practice maybe. Now we want to solve for this equation. Let's see what we can do about that. How about we simplify this equation first? Seems like tan theta if we put sine over cos instead, yeah. So we're going to do, so this is not a trig, an expression, and a number yet. You're going to have to simplify this first. Just use algebra, trig identities, and whatever. that you think should be. So this one, I'm just going to do that. Yeah, and you can multiply across by 5, where the left hand side here will just be sine squared theta, and then you multiply across by cos theta, you get that and this, right? Don't forget there's 2 terms there. Okay, well, of course we can use trig identity. Let's solve for sine. Yeah, so this is cos, because we also have 4 cos theta here. So 5, well, we put sine squared in terms of cos, that would be 1 minus cos squared theta equals cos squared theta plus 4 cos theta, right? So that's going to be 5 minus 5 cos squared theta equals cos squared theta plus 4 cos theta. Yeah. Moving everything to the same side, maybe the right hand side, I have 6 cos squared theta plus 4 cos theta minus 5 equals 0. I would like to try factorizing it first, so I'm going to go with 3 cos theta here and 2 cos theta, because those multiply to 6 cos squared theta. How about, no, 5 and 1 doesn't work. Okay, maybe not then, because I see that I can't find any 2 numbers that work. So let's do 6 and 1. So 5 and 1, nope. 1 and 5, nope. Okay, let's use quadratic formula. So cos theta is equal to minus b plus or minus square root b squared minus 4 times a times c, like that, all divided by 2 times a. Yeah, so that's going to give me minus 4. Well, what's inside the brackets there? It's 30 times 4 is 120, so it's 16 minus 120, so it's 104. Okay, so plus or minus, no, it's 120 plus 16, so 160, 120, 16, 136, yeah, divided by 12. All right, so I'm just going to get the 2 values here, basically. Okay, I'm just using the calculator. So it was 6, 4, minus 5. Okay, yeah, that should be right. If you cancel that, yeah, you should get minus 34 minus 2 divided by 6. What is this? That's over 1, right? Okay. And this one. So this one is over minus 1, or beyond the range of cos and sine, yeah? So we're going to get that one, which is, this is 0.638492. Yeah, let's make it precise first. Okay, now we get cos theta equals this, because we rejected one of them because one of them didn't work. Okay, now again, you have cos of some angle equals a number. And this is easy because the angle expression isn't that complicated. So cos of theta gives you a positive number, right? So that should be this quadrant and this quadrant for the cos. Okay, so the theta is already 0 to 360, and we don't need to modify that. So it's going to be this angle here, and then you got to sweep until you find the other angle, so that the angle is positive number. I mean, you could have swept here, but because we don't have, the range doesn't cover a negative angle. That's why we need to keep going positive. Yeah. Okay. So basically, theta is just arc cos of 0.638 ... and yeah, 360. Yeah, because you would, this is also the principal angle. So the principal angle is basically this. Yeah, this is the principal angle. But when you sweep to the other one here, is basically 360 minus that principal angle. All right, so I'm just going to do 360 minus arc cos of that. Right, like that. Okay, so go back to the calculator mode. So arc cos of, just going to go precise here, root 34 minus 2 divided by 6, right? Yeah. Okay, yep. So that's 50 point, we want 1 decimal place, so 50.3. And if I do 360 minus that, so that's 309.7, 1 decimal place. Yeah? Okay. Yeah, I'm just checking. Okay, so that's it. Number 9. Ooh, nice. Nice shape. We're at 54. Is this the last one? Oh, we have 10 questions actually. Okay, but we have time. Number 9, figure 2 shows a sketch of an open container. The sides CDEF and ABFE are rectangles. The NABADE and BCF are congruent, identical. Okay, it's just a cross section there. The container is made from metal of negligible thickness. Given that AB equals BF, AE equals BF, okay, and DE equals 2x, and AB equals DC equals EF, yeah, all the edges there. And the capacity of the container is 12 cubic meters. Show that the area of the metal used to make the container is that. Alright, so it's given you the volume. So we're just going to make an equation of volume. So volume equals 12 equals, well, the cross section is just 1/2, right, times, it's a triangle, so AE is 3x, that's the base, and then the height is DE here, which is given to be 2x, that's the area of the triangle of the cross section, and you're going to multiply that by the length, which is EF here, L. So doing this will allow you to make L in terms of x, yeah. So we're going to cancel 2 here, cancel 3 here. So that would be L equals 4 over x squared. Is that? Yeah? Yep, I think so. Okay. So L equals 4 over x squared, and then we find the area. So the area would consist of 2 triangles. So area S is just 2 of the triangles again, which is 1/2 times base times height plus all of the faces. We have 3 faces, this one, the back one, and the bottom one. So ABCD first, say ABCD. So AB is just L, which is 4 over x squared. That's AB. Times BC, which is AD. AD is a hypotenuse, so we need to do Pythagoras there. So this is square root of 3x overall squared plus 2x overall squared. That's AD. So AB times AD, that's the front face maybe. And then the back face, the DCFE here. So we have DE, which is 2x, times L again, DC, which is 4 over x squared. And then the bottom face is just AB times AE. So AE is 3x times the length again, 4 over x squared. So as you can see, there are terms with 4 over x squared multiplied, all 3 of them. Yeah, we can factorize that out, right? And the first one here is just 2 cancel, we have 6x squared, right? For that one, for that first term. And then I'm going to have 4 over x squared. And inside here I have this one. What is that? 9x squared plus 4x squared, that's 13x squared. So that's root 13 times x, right? And then we have, oh yeah, that's fine. Then we have here 2x and 3x, right? So plus 2x plus 3x. Yeah? Okay, so we want it to look like that, where q a positive integer. Wait, what? Positive integer? Interesting now. I don't get a positive integer for q. Okay, did I do Pythagoras wrong here? Wait. An open container. That's why. Because I got the square root 13 here from assuming that ABCD is a lid or something. We can see inside here, so there should be no lid here. ABCD face doesn't exist, basically, so I should cancel out this term, yeah? Okay, cancel out that term, so I only have these two. Like that. Yeah, we only have the face ABFE and DCFE. just 2. Okay, so that's just basically 6x squared for the px squared, and this will be 5 times 4 is 20 divided by x. Okay, so that should be fine for A. Part B. Use algebraic calculus to find the minimum of s, giving your answer to one decimal place. So basically we find ds by dx, that's just basically 12x, just differentiating that. And this one will be minus 20 divided by x squared. Yeah. So minus 1 bringing down, and minus 1 is minus 2. Yeah, so you get that. Now we put that to 0 because we want to find the minimum. So basically we have 12x equals 20 over x squared. So x, if you solve that, is going to be cube root of 20 over 12, right? Just solving that equation there, algebraically. So what do you have there? Square, cube root, sorry, it's cube root, yeah. 20 divided by 12. So x equals 1.18563, blah, blah, blah. Minimum value of s, right? We can plug that whole thing into the s there. So s minimum equals, right? Yeah. Okay, so it's just what's the equation again? P12, no, not 12, 6 x squared, so 6, and this guy, just gonna make it a index form like that, and then we need to raise that to the power of 2, yeah, and then plus 20 over this, basically, like that, yeah. So let's put that in a calculator, of course. So basically it's just 6 times fraction 20 over 12 to the power of 2 over 3. Yeah, that's the first term, because I multiply out the powers there. And plus 20 divided by, brackets, 20 over 12, close bracket, to the power of 1/3. Yeah? Just checking everything. Yep, I'm okay with that. So it's just 25.3, basically. Yeah, that's the value of s, giving one decimal place. Okay. Part C. Justify that the value of s found is a minimum. Well, we just do second derivative, right? d squared s by dx squared. Just take this, differentiate it again. So the first one I got 12. Yeah. And then the second one, it would be, so you bring minus 2 down because it's extra minus 2. So you bring minus 2 down, it would become plus 40. And the power decreased by 1, so you're going to have 3 down here. It's extra minus 3, which is the same as that. Yeah. And you're going to have to put, you have to make x equals that to check if it gives you positive or negative here, right? Okay. So 12 plus 40 divided by that. Oh, so the third cancel, right? So the third cancel because this is power of 3, so it's going to be 12 plus. So that cancel, that would be 20 over 12, and that would just be 40 over 20 times 12 instead. So that is 12 plus 24, that is 36, which is greater than 0. Right? So d squared s by dx squared is greater than 36, therefore a minimum. Right? As required. Okay, the last question. Number 10. Use algebra to prove by exhaustion that for all positive integers m that are not multiples of 3, the value of that is always a multiple of 3. Okay, so not multiple of 3, right? Not multiples of 3. So we have, for all positive integers m, so we have m. If you put 3k here, it's going to be a multiple of 3, right? So we do plus 1, not multiple of 3. And the other case is plus 2. because you can't go plus 3, because if you do plus 3, that would be the multiple of 3. Yeah, we don't want that. So we're just going to do these two cases. So we have m squared plus 3m plus 2 is going to be equal to, just going to put everything in here. Yeah, like that. And then we should simplify all this and extract, like, write in terms of multiple of 3. Yeah, okay. So that's basically expanding the quadratic there. So 9k squared plus 6k plus 1 plus 9k plus 3 plus 2. And I can factorize 3 out, but let's simplify that first. So 9k squared plus 15k plus 6, right? So if I factorize 3 out, I have this. Yeah? And this is an integer, isn't it? Hang on. Let's just do k is an integer here, natural number, like that. Yeah. Okay. So that means m squared plus 3m plus 2 is a multiple of 3. Yeah, and we're going to do the same for the other case. So m squared plus 3m plus 2 is going to be equal to same thing, like that, and plus 2 instead. Wait, hang on. Hang on. I'm a bit confused here in terms of okay, yeah, that's right. Okay, that's fine. So 9k squared plus 6k plus 4 now for this one, plus 9k plus 6 plus 2, right? So that would be 9k squared plus 15k again, but this time plus 12. So that is just 3 outside, 3k squared plus 5k plus 4, right? And this is again integer, because we would have k as a natural number there. So that means m squared plus 3m plus 2 is a multiple of 3. So this is by exhaustion, because you prove all the cases possible. Yeah? So from all cases of m, yeah, that is not a multiple of 3, m squared plus 3m plus 2 is always a multiple of 3. So it is a multiple of 3. Yeah, that's proved by exhaustion. And that is it, guys. I'm gonna mark the paper and come back shortly. Okay guys, I've marked the paper. Only lost 1 mark here. Already annotate the video, I think. So it was just reading the wrong line for the number of decimal places. So I lost that one, just the only one. So let's review the paper here, yeah? So from the first question, I think this paper is kind of in the range of easy to medium. I would say more to easy, yeah? Compared to previous years, at least in the January 2025 was also a bit easy, but November might be hard, right? So the November 2024 and the June 2024 might be harder, right? So this first one is fine, binomial expansion, and then you need to use the answer from previous part and compare the coefficient. So number 2, yeah, you need to know that when they give you 2 points like this, and they've done this before many times, ask you the equation of the circle, and yeah, B might be tricky if you don't visualize, right? So question 2B here, you need to visualize and know what to find. So it's just that little distance here, yeah, from the lowest point of the circle to x-axis, right? So that might be the tricky bit there that you need to be careful. This one, very classic. You integrate between two functions, but it's just that you need to find the line first because it doesn't give you that. So you need to know how to find the line equation and put them into the integrand here, like y1 minus y2. So we take the above minus the below. Yeah, so that's also classic. This one, yeah, factor theorem, remainder theorem. So this should be fine. Just be careful. I almost made a mistake here. I thought it only asked for remainder, but it also asked for quotient. So that might be where things can go south for some students, I think. Yeah, so be careful there. Just read the question thoroughly. Yeah, ironically, I didn't read this question thoroughly. So, you know, for question 5 here, I read this and see 3 decimal places, but that is just the things that they say to you here. They give you 3 decimal places, but they want the answer in 1 decimal place. Okay, so I double checked everything and I thought I got it right, but no. So just 1 decimal place here should have been 18.8. But for the other 2, they didn't say anything, so I carried forward the more precise value and still got the right answer there, so that's fine. I would put that as correct. Number 6, yeah, this one, just the 1 bit you need to be careful. I mean, I've seen all the students I teach make this first-hand mistake about not checking the value in the log argument. Although they know about that, sometimes they will just intuitively go with always the positive value. But sometimes negative values work. It really depends. It's not about being positive or negative. Just make sure you understand that. Because it's about what value gives you a negative number in the argument of the log. So you need to check all arguments. So the x plus 11 here and the 4 minus x here. In this case, the minus 2 works because it gives you positive, right? And the other one doesn't. Yeah. And this one is just solving an exponential equation. So I solve it exponentially here. I didn't take log on both sides at first, but I rearrange so that I simplify the indices there. And I got these answers, so that's fine. Number 7, yeah, this one is a little different from previous years, I would say, because they give you just the series, but they ask you just to find other things from that. So yeah, a little different in terms of, I think, the last question here, arithmetic series, yeah. So you need to figure out how to get a maximum value. So this might be a hard one here. Might be a hard one. Could have been worse if they put this into the context of real world problem like money or buying stuff or whatever. Yeah. So you got to figure out how to get a maximum possible value because this is all positive, but each of them, you know, like the consecutive ones keep decreasing. So there will be a point where you start to get a negative number adding up, which will deduct the value and get smaller and smaller as a sum, right? So you need to know that and make sure you go back and check that out again if you don't understand what I do here. Yeah. For this one. So this one is the right answer, 52,033. Yeah. Number 8. Yeah, cast diagram for both questions. So check out the video if you haven't. In the description, just check it out. I made a cast diagram walkthrough, like from the basic to examples. Yeah, so do check out. But yeah, if you are proficient in that technique, I can assure you can do all the trig equation, like the trig solving equation, as long as you arrive at the form that I told you, the trig, the angle expression, and the number. As soon as you arrive at that, the rest is just cast diagram. Okay? Always the same protocol, basically. Yeah. Okay. Number 9. Yeah, this one almost flopped. I mean, if it didn't show me this format, then I would have lost a mark here because at first I accounted for the open face here, which should be nothing, but I I took A, B, C, D here and added it in. Then I realized that, okay, this doesn't look like having a third, but because I did have a root 13 first, and then I realized, okay, that should be wrong now. And then I read the question again, and it starts with an open container. So, yep, I fixed that in time. And everything else is fine here. Proof that is a minimum, so classic. And number 10 is also classic when it says proof by exhaustion, but it looks like an algebra here, not really substituting actual values in. So this is how you do it mostly. If it was a multiple of 4, then you would have more work to do. So you would have to go 4k plus 1, 4k plus 2, 4k plus 3. Because 4k plus 4 would have been not like a multiple of 4. So we want to prove that any integer that is not multiple of 3, yeah. So that's why we did 2 cases here, the plus 1 and the plus 2, because they're not multiples of 3. And you should know how to do this. This is classic, right? Can come up any year, anytime. And that was it, guys. So if you've watched me this far, that means I think you find this video useful. Do check out other videos. I have walked through a lot of IAL math papers in the playlist and so on. And I hope to see you in the next video. Bye.